Berlin, Germany uses a 230 volts/50 Hz line voltage. There are two main plug types used: Type C, the Euro plug, which is a 2-pin unpolarized and ungrounded plug, and Type F, the Schuko plug, which is a 2-pin plus ground polarized plug. Because the Type C plug is unpolarized, you cannot determine which pin is neutral and which is hot from the plug itself. Here are some options. Firstly, use a transformer with a built-in rectifier. These transformers convert alternating current to direct current without requiring polarization. Secondly, if you have the necessary skills and equipment, you can mark the wires yourself using a multimeter. However, it's crucial to double-check your work before connecting it. Thirdly, if you're not comfortable wiring the transformer yourself, it's best to consult a qualified electrician in Berlin. As for determining neutral versus hot, with a multimeter, firstly, connect the red probe of a multimeter to one pin of the plug. Secondly, connect the black probe to the other pin. Thirdly, set the multimeter to alternating current volts mirrored. Fourthly, if the reading is close to 230 volts, you have the hot pin. If it's around 0 volts, you have the neutral pin. With a test light, use caution and only proceed if you have electrical experience. Firstly, strip the insulation off the end of a test light wire. Secondly, touch the bare wire to one pin of the plug. Thirdly, if the light glows brightly, you have the hot pin. If it glows dimly or not at all, you have the neutral pin. Always double check your wiring before connecting it to power. Handle electrical connections with care and follow all safety protocols. If you are not comfortable working with electricity, it's best to seek professional assistance. A key point to understand is that with an unpolarized plug like the Type C, there's no inherent way to distinguish between the hot and neutral wires directly from the plug itself. This is different from polarized plugs where the shape and orientation dictate which pin is which. This lack of inherent polarity in Type C plugs is why the advice focuses on using devices that don't require knowing the polarity or on using tools to determine it. Transformers with built-in rectifiers are a good solution because they convert the alternating current to direct current, and polarity becomes less relevant after the rectification process. It is important to elaborate more on the tools and methods for determining neutral versus hot, and discuss more about safety precautions. Let us look into a more in-depth and technical explanation and tutorial instead. Dealing with electrical systems, especially when differing voltage standards are involved, demands caution and a solid understanding of basic electrical principles. In this discussion, we will delve into the intricacies of wiring a 12 volts direct current LED project for use in Berlin, where the standard line voltage is 230 volts/50 Hz, while also addressing the challenges presented by unpolarized Type C plugs. The first thing to consider is the appropriate transformer for the job. A transformer's primary function is to convert the 230 volts alternating current from the mains supply down to the 12 volts direct current required by the LED project. Given the unpolarized nature of the Type C plug, the selection of the transformer and how it handles alternating current input is crucial. A standard transformer steps down the voltage but maintains the alternating current characteristic. The alternating current output then needs to be converted to direct current for the LED to function correctly. This is where a rectifier comes in. A rectifier is an electrical circuit that converts alternating current to direct current. It typically consists of diodes arranged in a bridge configuration. These diodes allow current to flow in only one direction, effectively blocking the negative half of the alternating current waveform and allowing only the positive half to pass through, albeit in a pulsating manner. Following the rectifier, a filter capacitor is often used to smooth out the pulsating direct current, providing a more stable direct current voltage to the LED circuit. A transformer with a built-in rectifier and filter integrates all these components into a single unit. This simplifies the wiring and ensures that the output is a clean, stable direct current voltage. When selecting such a transformer, ensure that it is rated for the appropriate input voltage 230 volts alternating current and output voltage 12 volts direct current, and that it can supply enough current, measured in amps, to power the entire LED project. The current rating of the transformer should be higher than the total current draw of the LED to prevent overheating and ensure reliable operation. If you choose to use a separate transformer and rectifier, you will need to wire them together. The alternating current output of the transformer connects to the alternating current input of the rectifier, and the direct current output of the rectifier connects to the LED circuit. Again, ensure that all components are rated for the appropriate voltages and currents, and that the wiring is done correctly, paying attention to polarity. Regarding the use of a multimeter, it is an invaluable tool for electrical troubleshooting and verification. To determine which pin of the Type-C plug is hot and which is neutral, you can use a multimeter in alternating current volts mode. However, since the plug is unpolarized, the reading you obtain will depend on the state of the alternating current waveform at the moment of measurement. The alternating current voltage alternates between positive and negative values 50 times per second in a 50 Hz system. Therefore, if you measure the voltage between the two pins, you will typically see around 230 volts alternating current, regardless of which pin you connect or which probe. This measurement confirms that there is voltage present, but it does not tell you which pin is hot and which is neutral. To determine the hot and neutral pins, you need to measure the voltage between each pin and a known ground. In a properly wired electrical system, the neutral wire is connected to ground at the service panel. Therefore, the voltage between the neutral pin and ground should be close to 0 volts, while the voltage between the hot pin and ground should be close to 230 volts alternating current. To perform this measurement safely, you will need a known good ground connection. This could be a grounded metal water pipe, a grounding electrode rod, or the ground pin of a properly grounded Type F Shuko outlet. Connect the black probe of the multimeter to the ground connection, and then use the red probe to measure the voltage at each pin of the Type-C plug. The pin with the higher voltage is the hot pin, and the pin with the lower voltage is the neutral pin. If you do not have access to a known good ground connection, you can try using a test light. A test light is a simple device consisting of a small light bulb and a probe. When the probe is touched to a hot wire, the light bulb lights up, indicating the presence of voltage. To use a test light to determine the hot and neutral pins of the Type-C plug, first make sure that the test light is rated for 230 volts alternating current. Then, carefully touch the probe of the test light to each pin of the plug. The pin that causes the light bulb to light up is the hot pin, and the pin that does not cause the light bulb to light up is the neutral pin. However, it is important to note that this method is not as reliable as using a multimeter with a known good ground connection, as it is possible for the test light to give false readings under certain conditions. Always exercise extreme caution when working with electricity, and if you are not comfortable performing these measurements yourself, it is best to consult a qualified electrician. Safety is paramount when working with electricity. Always disconnect the power before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and rubber gloves. Never work on electrical circuits in wet or damp conditions. If you are not sure about something, ask a qualified electrician for help. Wiring electrical circuits in a foreign country can be challenging due to differences in voltage standards, plug types, and wiring conventions. It is important to do your research and understand the local electrical codes and regulations before starting any work. If you are not familiar with the local electrical codes and regulations, it is best to consult a qualified electrician who is. Let's discuss more advanced topics. In many modern electronic devices, including LED power supplies, a technique called power factor correction, or PFC, is employed. Power factor is a measure of how effectively electrical power is being used. A power factor of 1 indicates that all of the power being supplied is being used to do useful work, while a power factor of less than 1 indicates that some of the power is being wasted. In alternating current circuits, power can be wasted due to reactive loads such as capacitors and inductors. These loads cause the current and voltage to be out of phase with each other, which reduces the amount of real power being delivered to the load. Power factor correction circuits are designed to minimize this phase difference and improve the power factor. There are 2 main types of power factor correction: firstly, passive power factor correction, and secondly, active power factor correction. Passive power factor correction circuits use passive components, such as capacitors and inductors, to correct the power factor. These circuits are simple and inexpensive, but they are not very effective at improving the power factor over a wide range of loads. Active power factor correction circuits use active components such as transistors and integrated circuits to correct the power factor. These circuits are more complex and expensive than passive power factor correction circuits, but they are much more effective at improving the power factor over a wide range of loads. If you are using an LED power supply with power factor correction, you do not need to worry about the power factor. The power supply will automatically correct the power factor, ensuring that the power is being used effectively. Another important consideration when wiring electrical circuits is electromagnetic compatibility, or EMC. Electromagnetic compatibility is the ability of a device or system to function properly in its electromagnetic environment without causing electromagnetic interference to other devices or systems. Electromagnetic interference, or EMI, is unwanted electromagnetic energy that can disrupt the operation of electronic devices or systems. Electromagnetic interference can be caused by a variety of sources, such as radio transmitters, televisions, computers, and industrial equipment. To minimize electromagnetic interference, it is important to use shielded cables and connectors, and to ground all metal enclosures. Shielded cables have a metal foil or braid around the conductors to block electromagnetic energy. Shielded connectors have a metal shell that is connected to the shield of the cable. Grounding all metal enclosures provides a path for electromagnetic energy to flow to ground, preventing it from radiating into the environment. If you are using an LED power supply in a sensitive environment, such as a hospital or laboratory, it is important to choose a power supply that is designed to minimize electromagnetic interference. These power supplies typically have built-in filters and shielding to reduce the amount of electromagnetic energy that they emit. In addition to power factor correction and electromagnetic compatibility, there are a number of other factors to consider when wiring electrical circuits. These factors include voltage drop, wire size, and circuit protection. Voltage drop is the decrease in voltage that occurs along a wire due to the resistance of the wire. Voltage drop can cause problems with the operation of electrical devices, especially those that are sensitive to voltage variations. To minimize voltage drop, it is important to use wires that are large enough to carry the current without excessive voltage drop. The size of the wire required depends on the length of the wire, the current that it will carry, and the allowable voltage drop. Wire size is typically specified in terms of American wire gauge, or AWG. The smaller the AWG number, the larger the wire. For example, 12 AWG wire is larger than 14 AWG wire. Circuit protection is the use of fuses or circuit breakers to protect electrical circuits from overcurrents. Overcurrents can be caused by short circuits, overloads, or ground faults. Fuses and circuit breakers are designed to interrupt the flow of current when an overcurrent occurs, preventing damage to the wiring and equipment. It is important to choose fuses and circuit breakers that are rated for the appropriate current and voltage. The current rating of the fuse or circuit breaker should be slightly higher than the normal operating current of the circuit, but not so high that it will allow an overcurrent to occur without tripping. The voltage rating of the fuse or circuit breaker should be equal to or greater than the voltage of the circuit. When wiring electrical circuits, it is also important to follow the National Electrical Code, or NEC. The NEC is a set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, so it is important to use the latest version. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Following the NEC will help to ensure that your electrical wiring is safe and reliable. In the context of wiring a 12 volts direct current LED project in Berlin, Germany, the NEC is not directly applicable, as it is a United States standard. However, the principles of safe wiring practices outlined in the NEC are universally applicable and should be followed regardless of the location. It is important to research and understand the local electrical codes and regulations in Berlin, Germany, and to follow those codes and regulations when wiring electrical circuits. If you are not familiar with the local electrical codes and regulations, it is best to consult a qualified electrician to us. Finally, it is important to remember that working with electricity can be dangerous. Always take the necessary safety precautions to protect yourself from electrical shock. Disconnect the power before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Never work on electrical circuits in wet or damp conditions. If you are not sure about something, ask a qualified electrician for help. Let us get back to the topic of LED. Light-emitting diodes, or LEDs, are semiconductor devices that emit light when an electric current is passed through them. LED are becoming increasingly popular for a variety of lighting applications due to their high efficiency, long lifespan, and small size. LED are available in a wide range of colors, brightnesses, and beam angles. When choosing LED for a project, it is important to consider these factors to ensure that the LED are appropriate for the intended application. The color of an LED is determined by the semiconductor material used to make the LED. Common LED colors include red, green, blue, yellow, and white. The brightness of an LED is measured in lumens. The higher the lumen output, the brighter the LED. The beam angle of an LED is the angle at which the light is emitted. A narrow beam angle produces a focused beam of light, while a wide beam angle produces a diffuse beam of light. LED typically require a direct current power supply. The voltage and current requirements of the LED will depend on the specific LED. It is important to use a power supply that is rated for the appropriate voltage and current to avoid damaging the LED. LED are also sensitive to heat. Excessive heat can reduce the lifespan of the LED or even cause it to fail. It is important to provide adequate heat sinking for LED to prevent them from overheating. Heat sinks are devices that are designed to dissipate heat away from electronic components. Heat sinks are typically made of metal and have a large surface area to maximize heat transfer. When mounting LED, it is important to follow the manufacturer's instructions. LED can be mounted using a variety of methods, such as soldering, gluing, or using connectors. It is important to ensure that the LED are properly mounted to prevent them from coming loose or being damaged. When wiring LED, it is important to pay attention to polarity. LED are diodes, which means that they only allow current to flow in one direction. The positive terminal of the LED must be connected to the positive terminal of the power supply, and the negative terminal of the LED must be connected to the negative terminal of the power supply. If the LED is connected backwards, it will not light up and may be damaged. LED can be connected in series or parallel. When LED are connected in series, the voltage drop across each LED adds up. The total voltage drop across the series string of LED must be less than or equal to the voltage of the power supply. When LED are connected in parallel, the current through each LED adds up. The total current through the parallel string of LED must be less than or equal to the current rating of the power supply. It is important to use current limiting resistors when connecting LED in series or parallel. Current limiting resistors are used to limit the amount of current that flows through the LED, preventing them from being damaged by excessive current. The value of the current limiting resistor depends on the voltage of the power supply, the voltage drop across the LED, and the desired current through the LED. The formula for calculating the value of the current limiting resistor is R equals V supply V LED/ILD, where R is the resistance of the resistor in ohms, V supply is the voltage of the power supply in volts, V LEDs is the total voltage drop across the LED in volts, and ILD is the desired current through the LED in amps.